Hi everyone, this is our first video of Chapter 1 and it's titled Section 1.2 Properties of Real Numbers. When I do these videos for you and I ask you to listen to them and take notes on them, that's basically exactly what I want you to do. I want you to listen to what I'm talking about. I want you to take notes on the material that I discuss. And I also want you to write down any questions that you might run into as I go through the examples. Sometimes it's hard to, still figure something out even though you have the ability to rewind and go through things again. You may still want to ask during class time in order to get some clarification on things. Unfortunately, the smartboard isn't working with the recorder because we don't have our tablets yet. So I've got to do this through an alternate recording method, which is not going to be the best. So I apologize up front for the quality of the video. Things will get a little bit clearer as soon as we get our permanent tablets and I'm able to incorporate the use of the smartboard with this. So please bear with me through the first couple sets of these. So as I said, the first section is called Properties of Real Numbers, and we're going to discuss some things I think you've seen before from other classes. We're basically going to be classifying the real numbers, and that means giving each number a category that they can fall into. The largest category of numbers is called the real numbers, and I drew a box on my slide here, and I want you to do that in your notes. So this largest box is going to encompass the idea of real numbers. Let me just pull up a pen here. I told you the quality of this is not going to be great, but you'll have to bear with me as I go through with the writing also. This is called the real number. The real numbers, and the abbreviation for real numbers is a capital script R. Real numbers are basically every number that you've dealt with up to this point in time. So it's the broadest category of numbers. Everything that you could name would be considered to be a real number at this point. I'm going to take the real number system, this box, and I'm going to break it down into two categories. One side is going to be a little bit larger than the other, so you should draw it that way in your notes. I'll switch colors here so that we can differentiate between things. And the first category is going to be the set of rational numbers. The abbreviation for rational numbers can't be an R because we already use it. The abbreviation is considered to be a Q, and that has some Latin and Greek derivation relationship. Rational numbers are basically numbers that can be written as quotients, so I believe that that's where the Q came from. These are your I shouldn't say non. These are your terminating and repeating decimals. These are numbers like the following: -5, -5/3, 0, 1/5, and I don't know, we could say 2.5. Each of these numbers are considered to be either a terminating or a repeating decimal. The terminating decimals end. -5 is -5.0. 2.5 ends. -5/3 would be considered to be a repeating decimal. That would be -1.6 repeating. 1/5 would be a terminating decimal at 0.2. So those are considered to be your rational numbers. The other broad category in the real number system is called the irrational numbers, and these are the ones that fall in this other box. The abbreviation for irrational numbers is I, and these are your non-terminating, non-repeating decimals. There's one really famous irrational number, and that number is pi. Pi is a non-terminating, non-repeating decimal. It goes on forever and ever and ever. Other examples of irrational numbers would be square roots of prime numbers, like the square root of 2 or the square root of 7. Something that would not be considered an irrational number, even though you might think it because it's a prime number, would be the square root of negative 11. We can't have a negative sign underneath a square root sign because that takes us out of the real number system. We'll talk about that a little bit later in the year. So no negatives underneath radicals, but any other prime number, the square root of 11, the square root of 13, would be considered irrational numbers. Now, the irrational numbers are basically considered to be like the black sheep of the real number system. There's no other category that falls beneath them. But within the rational numbers, we have a few other categories. So I'm going to draw some more categories that I can fit in here. Under the rational numbers are the integers. The abbreviation for integers is Z. Again, there's a Greek or Latin derivation connection there. We couldn't use I because those are taken up with irrational numbers. And these are positive and negative whole numbers. So things like -3, -2, -1, 0, 1, 2, 3, so on and so forth. So these are numbers whose decimal form is a 0.0, but they're positive and negative numbers, including 0. Under integers is the category of whole numbers. And whole numbers are numbers that, the abbreviation is W, that are not negative at all. So they're integers, but they're not negative integers, so that means that we're left with numbers like 0, 1, 2, 3, so on and so forth. So those negative integers get thrown out of the whole number group. Finally, the last set is the set of numbers that you started working with probably first when you learned how to deal with numbers. And those are counting numbers or natural numbers. So counting, or what we call natural numbers. The abbreviation is an N. And those are whole numbers with the exception of 0. So that means 1, 2, 3, so on and so forth. If you think about when you learned how to count, you probably started counting with the number 1, not the number 0. So in a nutshell, those are our classifications for all of the different types of numbers that you know and have worked with up to this point in time. The expectation is that I'm going to be able to give you numbers and you're going to be able to tell me what classifications we could put on them. Because I'm not working off of the smartboard, I'm going to do a few shorter videos. So I'm going to end this one. I want you to make sure that you write down any questions that you might have about this information and ask me during class, but we will definitely do some practice problems with this when I see you next. Thanks for listening to me.